So I'm going to do a video today on quantum numbers because after you've watched my other videos, you probably know how to do an electron configuration. Um, and quantum numbers kind of are the next step for an electron configuration. An electron configuration can put an electron in, an energy level in an orbital, but much like we can put a bunch of kids in the school building, um, we do assign them each um, student numbers, and then we can assign electrons certain numbers too. So I think I'm going to do scandium because it's 21 and it opens up a d orbital, which will be interesting for us, but it's also the first one to open up a d orbital. So it's pretty easy. So when you get out a periodic table, you're going to find that scandium is number 21. So its electron configuration is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Just like this. And don't mind the writing on the back. I'm just recycling because, don't want to waste paper. So if we add up these superscripts, 2 and 2 is 4, and 6 is 10, 12, 18, 20, 21. You look at scandium on the periodic table, scandium's number 21. Now, I can do an orbital notation for that too, and I'm going to try to make my orbital notation decently big, so it'll probably be on 2 lines, but that's okay because we know how to do orbital notations, and we know it doesn't have to be on all the same line as long as it follows the electron configuration. And I'm almost done putting in my 4s2s. And I got to remember to put in all 5 lines for that d orbital, even though I'm only going to use one spot of one line. Because I have to, when it opens up the d orbital, it opens up all the 5 at once. So there's my orbital notation for scandium. And you can see that it's following the Aufbau principle. It's building up, and then its valence electrons are actually right here because it's got in a 4 energy level, and then it drops back to the 3 to fill in the larger d orbital. So it's actually got 2 valence electrons, but that's not really what we're talking about today. It's just extra knowledge. So the 4 quantum numbers, N, L, M, and S. And it's really not hard. You just have to remember what they are and where they go. So N is the energy level. And we always get our energy level by looking at the big number here. 1, 2, 2, 3, 3, 4, 3. Okay? So any electron here is going to be in the 4 energy level. So let's make a note that N is energy level. L tells us what shape the orbital is. And so it can have, just like we have 4 orbitals, it can have 4 values. So if it's in an S, it's a 0. If it's in a P, it's 1. If it's in D, it's in 2. And if it's in F, which we don't really hit F all that much, but if it's in F, it's 3. And then M is the only one that is a little teensy bit confusing for people. You got to make a number line over your suborbitals. So S only has 1 suborbital, so it's a 0. And then I'm going to show you these here in a second. P has 3, so it's 0, negative 1, plus 1. And then D has 5, so it's 0, plus 1, plus 2, negative 1, negative 2. And then F, 0, plus 1, plus 2, plus 3, negative 1, negative 2, negative 3, and then S, there are up and down electrons, and I tried to be real, clear that we needed to have one pointed up and one pointed down when we're filling in an orbital. And so the S value, if you're pointed up, you're a plus 1/2. And if you're pointed down, you're a negative 1/2. So there is the number line. There's for S, there's for P, there's for D, there's for F, and then you see the S, and then there. Now all of these are available on the class, lecture notes in maybe a little bit more clear format. But I just wanted you to see them here on the video. So we can pick any electron and give it 4 quantum numbers. Okay, so the first one I'm going to do is the very first one here. That's known as the hydrogen electron because it's the only one that hydrogen has. And so applying energy level is going to be 1. Value is going to be 0 because it's in the s orbital. It's going to be 0 again because there's only one suborbital, one line to put electrons on in any s, and then it's pointed up, so it's plus 1/2. So those 4 numbers are 1, 0, 0, plus 1/2. And we just made our first set of quantum numbers. Now, I can pick any one. Now, I'm going to go up to one of those 4 s electrons. And I wish I would have done the other one, but I'm going to do that because I circled it in ink. So its energy level is 4. It's in the s orbital. That's a 0. It's pointed up. Oh, not pointed up yet, Mr. Burr. It's suborbital 0 because it's s, and then it's also pointed up, so it's plus 1/2. I wish I would have done the other one. We could have done a negative 1/2, but that's okay. We'll do another one. So we can do here any of these P ones too. So I'm going to circle this one. Now pause the video and see if you can think about what numbers are going to go in there. So the first one is 3 after you've gotten your answer. Then it's going to be negative 1 because of the number, it's going to be 1 because it's in the P. I'm getting ahead of myself. And then negative 1 because of the number line, and negative 1/2 because it's pointing down. So 3, 1, and that 1, 3 because it's in 3, 1 because it's in P. I almost skipped that one. And then negative 1 because it's in the first part of the number line, and the number line is going to look like this. See, you can write the number line right over your electron configuration. And then negative 1/2 because he's pointing down. And I'll do one more here. We'll do that one from D. So it's 3, and then negative 2 because it's in that first spot. And then I did it again. I skipped the second one. I skipped the azimuthal quantum number. So it's 3, 2, negative 2, plus 1/2. That's crazy. 3, 2, negative 2, plus 1/2. This is an 8-minute video, so I don't care that I skipped a couple of them. I fixed it, and then we're just going print on this one. So I'll see you at the next video.